Hello and welcome to this video. This video is 10th set of complex number problems, that is problem number 91 to 100. So as I always say that when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution, because that will help you deepen your understanding on the problems. So without further ado, let's get started. Problem 91 says that find the general equation of the straight line joining the points z1 is equal to 1 plus I and z1 is z2. This should be z2 is equal to 1 minus I. So we know that equation of a straight line is given by this determinant, where the line is between z1 and z2. So if you evaluate this determinant, you get z into z1 bar minus z2 bar minus z bar into z1 minus z2 plus z1 z2 bar plus minus z1 bar z2 is equal to 0. So we simply substitute the values and we evaluate. We get the final equation of line as z plus z bar minus 2 is equal to 0. Problem 92 says that if z1 z2 z3 are three complex numbers such that 5z1 minus 13z2 plus 8z3 is equal to 0, then prove that this determinant is equal to 0. So we are given that 5z1 minus 13z2 plus 8z3 is equal to 0. So z2 is equal to 5z1 plus 8z3 by 13, that is 5 plus 8. So by looking at this equation, we see that z2 divides the line segment joining z1 and z3. This should be z2 here, and this is z1 and z3. So z2 divides this in the ratio of 5:8. So this means that z1, z2, z3 are collinear. So we can have this determinant as 0 because that is the condition of collinearity. So find the length of perpendicular from P2 minus 3i to the line 3 plus 4iz plus 3 minus 4iz bar plus 9 is equal to 0. So we know that the length of perpendicular from any point z1 to a line a bar z plus az bar plus b is equal to 0 is given by mod of a bar z1 plus a z1 bar plus b by 2 mod of a. So simply substitute the values and evaluate those, you get 9 by 2 as the answer. Problem 94 says that if a point z1 is reflection of a point z2 through the line bz bar plus b bar z is equal to c, where b is not equal to 0 in the Argand plane, then prove that b bar z2 plus b z1 bar is equal to c. So we have this Argand plane, we have this horizontal line bz bar plus b bar z is equal to c, and we have 2 points z1 and z2, where z1 and z2 are reflection of each other. So clearly this point will be midline. So since this is midline and it falls on this equation on this line, so z1 plus z2 by 2, this should be 2, should satisfy this equation of line. So b into z1 bar plus z2 bar by 2 plus b bar z1 plus z2 by 2 is equal to c. Now since the line segment z1 z2 and this line are perpendicular to each other, so slope of z1 z2 plus slope of line would be 0. So we can say that z2 minus z1 by z2 minus z1 minus b by b bar is equal to 0. Sorry, these are bars, z2 bar and z1 bar. So this is equal to 0. Now we have two equations, one is here, one is here. You solve these two, you will get the desired result. Problem 95 says that the point represented by the complex number 2 minus I is rotated about origin by an angle pi by 2 in the anti-clockwise direction. Find the new coordinates. So we have this point P, which is 2 minus I. It is rotated in anti-clockwise direction by an angle pi by 2. So we have to find P prime. So P prime would be z into e to power I pi by 2. Okay, that from the multiplication formula. So we substitute, we expand this e to power I pi by 2 in terms of cos and sine. We get cos pi by 2 as 0, and I sin pi by 2 will be I, because sine pi by 2 is 1, so it is 2 minus I into I is equal to 1 plus 2I. Problem 96 says that a particle P starts from the point z0 is equal to 1 plus 2I. It first moves horizontally away from the origin by 5 units and then vertically away from origin by 3 units to reach a point z1. From z1, the particle moves square root of 2 units in the direction of vector I plus j, and it then rotates about origin in anti-clockwise direction for an angle pi by 2 to reach z2. Find the coordinates of z2. So our given coordinate is 1 plus 2i. So since it moves horizontally 5 and 3 points vertically, so 1 plus 5 would be 6 and 2 plus 3 would be 5. So new coordinate would be 6 plus 5. Excuse me. Then it moves in the direction of I plus j for square root of 2 units. So this vector makes an angle pi by 4 with x-axis. Okay, this is 1, coefficient is 1, coefficient is 1, so it will make angle pi by 4. The new coordinates would be 6 plus square root of 2 cos pi by 4 and 5 plus square root of 2 sin pi by 4. That is 1 for both the cases when you evaluate them. So it becomes 7 plus 6i. Excuse me. It then rotates by angle pi by 2. So new coordinate would be 7 plus 6i into e to the power I pi by 2. E to the power I pi by 2 we know as I. So it becomes minus 6 plus 7i. Problem 97 says that a man walks a distance 3 units from the origin in northeast direction. Then he walks 4 units in northwest direction, finding the final coordinates. So northeast direction, as we know, makes an angle pi by 4 with x-axis. So coordinates of 0.3 units away from origin in northeast direction would be 3 into e to the power I pi by 4, which is 3 by root 2 plus I into root 3 by square root of 2. Excuse me. Northwest direction makes angle of 3 pi by 4 with x-axis. Now, a displacement of 4 units in this direction will mean that the coordinates would be 4 into e to the power I 3 pi by 4, like this one. So it is 4 into cos 3 pi by 4 plus I sin 3 pi by 4. Now you evaluate this, you will get minus 4 by square root of 2 plus I sin 4 by square root of 2. So you add these two, you will get minus 1 by root 2 plus I 7 by root 2. Give me a moment, I'll need some water. Problem 98 says that if 3 complex numbers satisfy the relationship z1 minus z3 by z2 minus z3 is equal to 1 minus I root 3 by 2, then prove that z1, z2, z3 form an equilateral triangle. We are given this z1 minus z3 by z2 minus z3. So we multiply with complex conjugate and divide by that. So this is 1 plus I root 3 and this 2 is wrong. This should be also 1 plus I root 3. So we get 2 by 1 plus I root 3. Now we take reciprocal of the values. We get z2 minus z3 by z1 minus z3 is equal to 1 plus I root 3 by 2, which is cos pi by 3 plus I sin pi by 3. Now modulus is 1 and argument is pi by 3 here. So the triangle is equilateral because the argument is pi by 3. Problem 99 says that if z1, z2, z3 form an equilateral triangle, then prove that z1 square plus z2 square plus z3 square is equal to z1, z2 plus z2, z3 plus z3, z1. And hence 1 by z1 minus z2 plus 1 by z2 minus z3 plus 1 by z3 minus z1 is equal to 0. So we know that like previous problem, sides of an equilateral triangle make an angle of 60 degrees with each other. So we can say that z3 minus z1 by z2 minus z1 is equal to 1 plus minus I square root of 3 by 2. So after that, it is simply a matter of solving the equations. So you can see how this has been solved. So I'll not read it out for you. You can do that. At this step, I have divided with z1 minus z2 into z2 minus z3 into z3 minus z1, and I have arrived at this result. Okay. At this step, I have added and subtracted z1, z2, z2, z3, and z1, z3. So that's it. Once you understand this concept of 60 degree, rest of it follows easily. Problem 100 says that if z1, z2, z3 are vertices of an equilateral triangle and z0 is the circumcenter, then prove that 3z0 square is equal to z1 square plus z2 square plus z3 square. So since it is an equilateral triangle, we know that in an equilateral triangle, centroid, circumcenter, and center, all of them lie at the same point. So circumcenter will be same as centroid. So z0 can be written as z1 plus z2 plus z3 by 3. And for equilateral triangle, we have proven that z1 square plus z2 square plus z3 square equal to z1, z2, z2, z3 plus z3, z1. So you multiply with 3z0 and take square of both sides. You get 9z0 square is equal to z1 square plus z2 square plus z3 square plus 2 into z1 z2 plus z2 z3 plus z3 z1. We substitute this term in bracket with z1 square plus z2 square plus z3 square, and then it is a simple matter of simplification, and you get 3z0 square is equal to z1 square plus z2 square plus z3 square. So with this, we come to the end of 10th set of problems on complex numbers. And in the next video, we'll solve 10 more problems on complex number. I hope that you have found this video useful. So please subscribe to the channel and like the video so that it can reach many more students like you and they can also benefit from this. So I sincerely hope that you have been enjoying this series of videos, and if you have a comment, let me know in the comment section, and I'll see you in the next video. Thanks a lot. Bye.